Hello, I'm Bill Richmeyer. I'm a representative of the Otsego Lake Watershed Supervisory Committee representing the town of Springfield, New York. And as a retired physician, wanted to have the medical effects of cyanobacteria toxins available information to the people that live in this area and may encounter the potential for mycobacteria blooms that can occur in the lakes. So that we wanted to just have people be aware of how they can get ill. I'm not an expert in this specifically. I do have training in microbiology and human medicine, uh, but this slideshow really isn't intended to provide specific health recommendations or advice, but rather to have things for our leaders so they can make choices on their own and understand how hard it can be to get timely information about exactly what's going on in the lake at any given time. We'll get to that at the end. My information has been gathered from online webinars, information from the state and national sites, in addition to interactions with other members of our watershed committee who've been very helpful in getting this together. So um, this is intended for the non-scientist, non-medical person that lives in northern Otsego County. It's focused on understanding about how people come in contact with cyanobacteria toxins and the symptoms they cause and how to avoid them. But there's a lot of important information about cyanobacteria identification, their biology, that we really don't have time to dwell on in this presentation. And they can be provided through the EPA, the DEC, the Otsego County DOH, OCCA, and OLA, and other organizations that can contribute with this information. So to start with, the cyanobacteria evolved about 3.5 million years before there was free oxygen. And they came to the Americas long before any other humans or other land animals have been here. So they're not an invasive species. The cyanobacteria were the first organisms to invent a way to capture solar energy and use it to produce chemically stored energy to make molecules necessary for life. Their power to split dissolved oxygen that was in the form of water, obviously, and carbon dioxide, freed the atmosphere, allowing it to become more complex so that organisms that used oxygen can evolve. The competition then for the nutrients, such as nitrogen and phosphorus, were substantial because of their ability to grow quickly. And the cyanobacteria toxins probably must have been some competitive advantage for these simple bacteria to continue to exist and populate the entire world. You can find them pretty much anywhere in the world currently. So they're produced inside the bacteria and often released into the water during what's called a bloom, or a harmful algal bloom, or an HAB, which is a misnomer. They were given this name before there were microscopes because they had this green or blue-green color. The toxins are very small, much smaller than the bacteria, which is really truly tiny. They're colorless, odorless, tasteless molecules. There are many types of toxins, and we're only going to talk about the ones that are most common in our area. And we don't refer to them specifically by any tissue target, which would be a much longer presentation if we wanted to do that. So the cyanotoxins are shown here in this little illustration that I put together. And over on this left-hand side is the bacteria growing. And these little dragons that are inside represent the toxins. And as they grow, they will spontaneously release some, but mostly they stay inside the cells. Now, when they interact with people, one of the things that people try to do to make water better for drinking is to boil it. And this would kill the cyanobacteria cells, but it doesn't affect the toxins. They're released into the environment around it. Unfortunately, they don't keep people from getting sick if the water's been boiled. The other way is they can get physically broken up, and that can happen by little microscopic organisms eating them, being chewed up, or freeze thaw that the scientists use to break them open so that they can assay all the toxins that are in this area. Is another way of getting them free in the liquid. And they also could be dissolved by enzymatic digestion. So if someone were to swallow them and went into their gut, where the digestive things would break down the cell membrane, would disintegrate and release the molecules. So if we have a cell that's still alive, we can add filtration, and this may pop up behind this screen. It's got a little diagram here of the uh, toxins that are in the bacteria separated from the free in the water, but that it doesn't do anything to really clean them out. So the filtration that's usually used to get rid of bacteria doesn't help get rid of the toxins, unfortunately. And you wouldn't want to drink that water even after it's been filtered. So here's what we're going to talk about: the incidence of cyanobacteria associated diseases, what kind of symptoms occur in humans, and how we come in contact with the toxins. And then what about dogs? Because this is a big issue. And you'll see when we get there that the dogs can get sick a lot faster than humans. And then do humans ever get really sick? And that is something you just need to know about, but isn't really a risk for us here in upstate New York. And what we can and can't do about safe drinking water, how doctors treat cyanotoxin illness, which is short, and you'll see why, and how to know if our lake water is safe.